Okay, so today we will start with logarithm equation. We are left with only three lectures 7, 8, 9. I think we can complete it by today. Lecture 9 is very small. Lecture 7 is also little bit small. Lecture 8 is a bit more. So we will try to complete all those by today. So let's continue. So logarithm equation. Lecture 8 is okay. So I think we are there. So in logarithm equation, we are told that there will be some equation. There will be some equation where we are told that log x base a is equal to log y base a. So we have some equation in x and y. Then we can say that x is equal to y and x should be bigger than 0, y should be bigger than 0, and x should not be equal to 1, y should not be equal to 1. This is what we will have to do. Okay, and a should be bigger than 0. X can be 1. Okay, x can be 1, y can be 1. A should be bigger than 0 and a is not equal to 1. These all are the things we have to check. First of all, we will remove the base. We'll start solving x equal to y. From there, we'll get some value of x in the term of y. So this is the first checking we will do. Second checking we will do that x should be bigger than 0, y should be bigger than 0. And fourth checking will be a should be bigger than 0, a should not be equal to 1. So these are the 5 checking we will do while solving this equation. So I will take one example. Here we have log 4x minus 3 base x. So by that what can we say is that the base x should be bigger than 0 and x should not be equal to 1. This is the first condition for the base. Second condition, something going inside log as an argument. This is base checking. Second is argument checking. Four x minus 3 should be bigger than 0. From there we can say x should be bigger than 3 by 4. Okay. So x is not equal to 1. X is, and third checking will be we will send x this side. So we can say that 4x minus 3 is equal to x square, which implies x square minus 4x plus 3 equal to 0. From here we can say that x is equal to 1 and 3. Okay. So we are told that x is not equal to 1, so this will get rejected. X is bigger than 0, x is bigger than 3 by 4, and x is not 1. So x equal to 3 is satisfying all these conditions. The 3 is bigger than 3 by 4, 3 is bigger than 0, 3 is not equal to 1. So we have one solution, x equal to 3. So we will be checking first base, second argument, And third, solving the equation. Okay, this is we solved the equation. Solving the equation. Okay, moving to next question. Okay, this type of question we have already solved. If you check, if you check, this 2 will go here, it will become 2 to the power 0, which is 1, which is 1. We will send 3 this side, it is log base 5 x square plus 4. This is 3 is to power 1, which is 3. Third, we will send 5 to the power 3, which is x square plus 4 equal to 5 to the power 3. We have x square equal to 125 minus 4. This is x square equal to 121. This will imply x equal to plus minus 11. So we have solved the equation. We will try to put x equal to plus minus 11 in this equation. We'll get 121 plus 4, 125. So log 125 base 5. So from here we'll get 3 out. The outcome will be 3. So log base 3 is 1 and log 1 base 2. So both the values are satisfying the equation. Okay. So our first step is checking the base. So we are not facing problem in the base. Second is checking the argument. So this number is 4 or more than 4. And third is solving the equation. So in this case we got only one case, which is solving the equation. Okay, moving to the next. So first step is checking the base. So 2 is not equal to 0, 2 is bigger than 1, 2 is not equal to 1, 2 is bigger than 0. Yes, so no we could check base checking. This is done. Second, argument checking. So argument it is what? X square should be bigger than 0 and x plus 2 should be bigger than 0. So from here if you see x square is bigger than 0, that means we know the to plot the number, it is 0, will start with plus and it will stay plus, and 0 is not included. That means we are getting x belongs to r minus 0, and here we are getting x is bigger than minus 2. So if you combine both of them, we'll get x belongs to minus 2 to 0, union 0 to infinity. So this is the outcome we got from argument checking. Third, we will normally solve it. So log m base 2 plus log n base 2 is nothing but log 2 base x square x plus 2, which is equal to 4. So it will go 2 to the power 4, which is 16, x square, x plus 2. Since we have already checked the argument, we need not check here. Now, can we go by hit and trial, or we can go by this way: x cube plus 2x square minus 16 equal to 0. If we see hit and trial, in cubic we have hit and trial always. By hit and trial, we can say that x is equal to 2. 2 cube is 8, 2 to the 4, 8, 8, 16. So x is 2. Okay. And second what will happen? Uh, we'll have x minus 2. We will divide x cube plus 2x square minus 16. It is x square, x cube minus 2x square minus plus 4x square minus 16. It is plus 4x square minus 8x. We'll get 8x minus 16. So we'll have finally plus 8. So if you see here, the discriminant of this is less than 0. The discriminant of this is less than 0. Discriminant is less than 0 implies no real roots. So we have only one solution, x equal to 2. So before going with this combination and everything, 2 is falling in between 0 to infinity. That means x equal to 2 is the solution. Moving ahead, 3 can go on the top of x, that means x cube, and 3 are base, so it will be directly x cube equal to 27, x equal to 3. We got it. So if we put 3, x should be bigger than 0, so x is bigger than 0. Yes. Second one, this is a quadratic. If we consider t equal to log x base 10, can we say it is t square minus t minus 6 equal to 0? If we try to find the roots, what are we getting? We are getting somewhere t equal to 3 and t equal to minus 2. Yes, product of the root, sum of the root. Okay, so t is what? Log x base 10 equal to 3, log x base 10 is equal to minus 2. We will simply get x equal to 10 cube, and we will simply get x equal to 10 to the power minus 2. So if you look for the first case, the base is always bigger than 0 and not equal to 1. So base checking is done. Second, we are checking argument. So x is the argument. So x should be bigger than 0. So these both values are bigger than 0. Hence both are the solution. You got it? We will separate this. Okay. So I would mind people to solve these questions. Okay, now this one is, if we consider t equal to log x base 7, can we say it as 3t? If you remember, it is nothing but 1 by t, which is equal to 10. So we simply got into quadratic form. We'll take t LCM, we'll get t square plus 1 equal to 10t. We get 3t square minus 10t plus 3 equal to 0. On solving, t is equal to 10 plus minus root under b square minus 4ac upon 2a, which is 10 plus minus 8 by 6, which is nothing but 3, 1 by 3. So we can say that log x base 7 is 3, log x base 7 is 1 by 3. From here we can say that x is equal to 7 cube, x is equal to 7 to the power 1 by 3. If you look here, for the base verification, x should not be equal to 0, and x should be bigger than 0, and x should not be equal to 1. So we are, both the case are getting satisfied for the base checking. Now it's argument, so x is bigger than 0, so we got both the argument, isn't it? Okay, now we'll go with this thing. So this is the good question out of all the question. Okay, out of all this question, this is the good question. So we will take log both the sides, log base 2 both the sides. So when we'll take log base 2, this log will come out down. It will be somewhere log x plus 2 base 2 into log x plus 2 base 2. That means it will become a square. And here we'll have, this is as m, this is as n. So log 8 base 2 plus log base 2 x plus 2 whole square. So if you take x plus 2 base 2 as t, it is nothing but t square minus, like x plus 2 will have to be positive. Okay, so we are keeping positive part only. So minus t minus 3 equal to 0. We'll find the value of x and we'll try to put in the equation. Like this is positive, so if it is mod, it will have to be positive. It's a 2t. Okay, my saying is that it will come out with some mod. So we'll consider this as positive only, because x plus 2 is positive. So this is a positive term, 2 will come out, and this positive term will stay. So this is 2t. If you try to find the value, we are going to get t equal to uh, 3 and t equal to minus 1. Product of the root is minus 3. Sum of the root is minus 2. Yes. And we know that log x plus 2 base 2 is 3. So x plus 2 is nothing but 2 cube, and x is equal to 6, and here we'll get log x plus 2 base 2 as minus 1. So we'll get x equal to 1 by 2 minus 2, 1 by 2 minus 2, minus 3 by 2. So minus 3 by 2, if you put minus 3 by 2 in the equation, it is 1 by 2, it is 1 by 2, it is 1 by 2. So it is possible. And if you put 6, it is also possible. So we have two solutions. So further moving ahead, we have enough space for that, okay? I think the first question we have solved earlier. This question also we have solved. This type of question also we have solved. So if you want me to solve, I will start solving. So it will help you to get all the revision. First, let me check up to how much we are going. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 21. Okay, we have 21 question, and in every question we have to explain the same routine thing. Okay, so no problem, you will get a better practice for the questions. I would have moved a bit faster, but since it is online, I will have to go with all those calculation. So first question we have solved in one of the solved example. Second question also we have solved. Okay, third question I am solving. Okay, those question we have already solved, we will skip those question. So it is third question. This is nothing but 2 square log x base 2 minus 2x minus 3 equal to 0. 2 will go to the power of x and 2 to same. We will get somewhere x square minus 2x minus 3. And we have recently solved this problem. We got x equal to 3, x equal to minus 1. So in argument condition, x cannot be negative. So this is rejected, this is taken. Now we are on the fourth. So we are on the fourth, let's solve it. So 4 could be written as 2 to the power 2, isn't it? Because our aim is to make it same. So if it is 2 to the power 2, it will come out to be 1 by 2. So it is nothing but 1 by 2 log 2 log x base 2 plus log 2 log x base 4 equal to 2. If we would like to multiply to both the sides, okay, let's multiply, and let's multiply and what, let's multiply. Okay, so we'll go by step to see where we could do something faster. Okay, it is 2 log base 2 log x base 4, and this is 4. If you bring out 2 to the power 2, it will become 1 by 2, it will go root x. Can we do? Okay, let's do. From here we will have 2 to the power 2, so 1 by 2 will come outside. Okay, write it clearly, we should write it clearly, isn't it? It is 2 1 by 2, it is there. Okay, so both the, so 2 will come on whole square. Okay, so we'll write one more step to see how the things work. This is log base 2 1 by 4 log x base 2 whole square equal to 4. If you take log m plus log n, we get log base 2 log x base 2 into 1 by 4 log x base 2 whole square equal to 4. Going furthermore, we'll send 2 to the power 4, which is 16, equal to 1 by 4 log x base 2 whole cube. So if you see, it is nothing but 4 square into 4. So log x base 2 is 4. Hence x is 16. So when it is 16, if you put 16 here, it is 4, the outcome will be 4. Log 16 base 2 is 4, log 4 base 4 is 1, 16, 2 will come same. Okay, so this is validating. Okay, this is correct. We'll go with the fifth one. We'll go with 3 to the power 2x, which is nothing but 9 to the power x. We have log x base 9 plus 1 by 2 plus 9 to the power x. This will get cancelled. We'll get log x base 9 equal to minus 1 by 2. Now we'll get 9 to the power minus 1 by 2, which is nothing but x equal to 1 by 3. Okay, so now we'll take x equal to 1 by 3 and put here. So this will get minus 1 by 2 plus 1 by 2 cancel, log 3x 2x. Okay, we'll get the correct answer. Okay, like we are putting this to verify whether the argument is coming zero, coming negative or not. We are putting here to check whether the argument is positive or not, and we are solving and we are checking everything. So first, by solving the equation, we are getting some value, and after that we are putting those value in the given log and try to see whether it is validating or not. So it's a validating. Okay, so now we'll go to question number 6. Question number 6. Okay, it is 2 log 4 minus x base 4, which is equal to 4 minus log base 2 minus 2 minus x. I think this is the requirement. So if we have something clumsy in the sense something difficult, what should we do? We should follow the rule. First, base checking. 4 2 all are correct. Second, argument checking. 4 minus x should be bigger than 0 and minus 2 minus x should be bigger than 0. That means x is less than 4 and x is less than minus 2. So overall we can say that x is less than minus 2. Okay, this is the condition, like whatever value of x should come, it should be less than minus 2. Then we can say that okay, it is correct. Now what will happen? From 4 we'll take 2 square. So it is 2 base 2 log 4 minus x base 2. This is 4. This is minus log base 2 minus 2 minus x. 2 cancel. We'll send it this side. It is nothing but log base 2 4 minus x into, this will come this side, it will become plus. So plus will come in the form of minus. It is log x minus 4 x plus 2 base 2 equal to 4. 2 will go to the power. It will become 2 to the power, which is 16, and we have x minus 4 x plus 2. If you start solving, it is x square minus 2x minus 8 equal to 16. If you go further, it is x square minus 2x minus 24 equal to 0. Now we will start finding the value. I think it's a 6 into 4. So x equal to 6, x equal to minus 4. Product of the root is minus 24, sum of the root is minus 2. If you see, using quadratic equation, and we are told that x should be less than minus 2. That means I think this is correct. This is going to be rejected. So we have only one value, isn't it? Seventh number. X to the power, okay, seventh number. Seventh number, we are going to have x to the power log 2x, x to the power log root x 2x. So everyone see that I am solving very nicely. So x to the power 1 by 2 will come out to be 1 upon 1 by 2, which is nothing but x square log base x 2x equal to 4. Then we'll go with 2 will go to the power of 2x, which is nothing but log base x 2x whole square equal to 4. Now x, both the base are same, so we'll simply get 2x whole square equal to 4. And now this is nothing but 4x square, so it will become x square equal to 1. We can simply say x is equal to plus minus 1. Now if you see here, x cannot be minus. Inside root, x equal to minus is rejected, and x equal to 1. The base cannot be x equal to 1, so both the values are rejected. We can say that it has no solution. Can we say that it has no solution? Yes. Okay. Now we are moving to question number 8. Question number 8. So now we are moving to question number 8. In question number 8, we have something x to the power zero point 0.5, which is nothing but 1 by 2. We have question like x to the power 1 by 2. First I will write the question, okay. Log root x square minus x equal to 3 to the power log 4 base 9. So from root x we will get 1 by 2 at the bottom. 1 by 2, 1 by 2 will get cancelled. We are simply left with log base x square minus x equal to 3 log 3 square 2 square. So 2 will come, 2 will come. I think both are going to get cancelled. Here if you check this base is same, so we'll directly get x square minus x. So 2 will come, 2 will come. So we'll get 2 as base. And then we are left with x square minus x minus 2 equal to 0. From here we can say that x is 2, x is minus 1. On solving, how to solve? X equal to minus b plus minus root under b square minus 4ac upon 2a. This is b, this is a, this is c. So from here we got this. Now if you see here, x cannot be negative. On putting 2, 2 to the 4 minus 2, which is 2. So argument will be positive and on x equal to 2, and root 2 is also correct. 2 is also correct. So only one value is there. I think you got it. Yes. Now what will happen is that I will be solving these questions also for you all. Okay. First question is, you will solve a quadratic. You are going to get the value of x, multiple value of x. So product of the value of x, if it is x1 and x2 and x3, you will multiply all three, you will get product of the roots. So question number 1 I am going to skip. Question number 2. Question number 2, this is 4 to the power x and we have 7 into 2 to the power x plus 6 equal to 0. This could be written as 2 to the power x whole square. We are just trying to form it in the form of quadratic. T square minus 7t plus 6 equal to 0. You get the value as t equal to 6, t equal to 1, and t is nothing but 2 to the power x equal to 6, 2 to the power x equal to 1. If you take log x, log base 2, we'll get x equal to log base 2 6 and x equal to log 1 base 2, which is 0. So sum of the root is what? This is x1, this is x2. So sum of the roots is x1 plus x2, which is log 6 base 2. I think you got it, isn't it? Question number 3. Question number 3. It is log x base 10. This is alone and plus 2 is alone. Okay. This is alone and plus 2 is alone. We'll take log both the sides. Log base 10 both the sides. We'll get log x base 10 plus 2. It is alone. Okay. This is alone. And we have log x base 10. It is alone. And here log 10 base 10 is 1, so we will get log x base 10 plus 2. Now we have a quadratic, we can solve the quadratic. Can't we solve it? T square plus 2t minus t minus 2 equal to 0. We have t square plus t minus 2 equal to 0. T will be equal to minus 2, t will be equal to 1. So log x base 10 is minus 2, log x base 10 is 1. So x is 1 by 100, x is 10. So if you put x equal to 10, this is correct, this is valid, this is valid. X equal to 1 by 100, all are valid. So we have two answers. Fourth one, you can take log both the sides and you are getting the same thing. So fourth one I am skipping, solve it. This question we have taken in the class. So this question we have taken in the class. What I want to tell is that it is nothing but log base 10 x square minus log base 10 2x minus 75 is equal to 2. If we this will come out to be log base 10 x square upon 2x minus 75, which is equal to 2. This will go to 10 square, which is 100. This is x square upon 2x minus 75. This is x square 100 2x minus 75. This is x square minus 200x plus 7500, which is equal to 0. Now sum of all the solution of x. First we will find the value of x1 and x2. If it validates, then if both of them validates, the sum of the root is 200. If one of them validates, then the sum of root is only one of them. So can you find the value of x? Okay, I am helping you to find x equal to minus b plus minus root under b square minus 4ac. So 4ac is what? 30,000. It is 2a. We are getting 100 plus minus, this is 1 lakh, maybe 1 lakh or 1000. It will come out to be 100, which is 50. This is 150 and 50. So 150, if you put 50, 150 minus 75, correct? 50, correct? We are checking whether it is valid on argument or not. 150 is also correct. So some of the roots are nothing but 200. 150 plus 50. Got it? if the solution, okay, alpha beta cases are given. So I am solving this question. We can simply write this as log 125 plus log x whole divided by log x. We are multiplying this with log x whole square upon log 25 whole square, which is equal to 1. This could be written as 3 log 5. This is log x. I think one of the log x will get cancelled. We are getting log x, and here we'll get 4 log 5 whole square. Now what to solve? It's a quadratic. Log x, we'll put log x equal to t. Simply going, it's a t square plus 3 log 5 into t minus 4 log 5 whole square equal to 0. So when you solve this, it is nothing but t equal to minus b plus minus root under b square plus 4ac upon 2a. This is 25, 5 log 5 whole divided by 2. The answer is log 5, and the answer is minus 4 log 5. So what will happen? T is nothing but log x. So if you put log x is equal to 5, x is equal to 1 by 625. So if you put here in the base, both the value of x is satisfying the base, isn't it, as well as argument. Okay, so the value of 1 upon alpha beta, alpha is less than beta, this is alpha, this is beta, so 1 upon alpha beta is nothing but 125. We got it. Now this question is similar to the previous question. I would like you all to solve this question. This question is also simpler question. It is 1 by p, 1 by p, 1 by p to the power 1 by p. It is 1 by p to the power n. So the answer is simply n, okay, which is independent of p. It is what saying is that log p and this is log base p, and we have p to the power 1 by p, 1 by p dot 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 1 by p n times. So it could be simply written as log base p, log base p, p to the power, if you see 1 by p, and 1 by p is 1 by p time, it is nothing but 1 by p square. So it is 1 by p to the power n. So from here we'll get log p 1 by p to the power n, and it will get minus n. So independent of p, option A, independent of p and of n. No, dependent on p and both positive note. So only one answer is correct, A. This question could be solved by you all. I am just giving you hint. Hint is what? It's a 3 root 2. So I am solving only x log 3 root 2 whole square 3 root 2 equal to 1 by 3. So 2 will come out to be 1 by 2, and log 3 root 2 base root 3 root 2 is 1. So it is nothing but log 1 by 2 base x is equal to 1 by 3. You can simply say that x to the power 1 by 3 is equal to 1 by 2, and you can simply say that x is equal to 1 by 8. Yes, cubing both the side, x equal to 1 by 8. And now when you put x equal to 1 by 8, it is correct. The base is getting satisfied by x equal to 1 by 8. Yes, now we have 1000x. 1000x meaning 1000 by 8, which is nothing but 125. Okay, so this is the answer. This is the first step, and this is the second step. This is minus x squared. I think we have solved something like this. You can solve it. In this question, uh, the graph of x base x and the base, both the base are x, so this is simply x square. So the graph of x square is this 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 is not x square. Okay, so the graph of x square is there. X cannot be 1, and negative side x cannot be negative. So I think option B is correct. X cannot be 0, x is not equal to 1, x is bigger than 0. So option B is correct. I think this is J advanced previous year question. I believe this is J advanced previous year question. So we are given A and B. Oh, we are given A and B, and we are given C also. So this has come out to be simpler question. This is nothing but 4 4 square. A is nothing but 4 square plus 9 log 9 base 3 equal to 10 to the power log 83 base x. Now from here 1 by 2 will come out, it will go to the power 4, it will be 2, 3 square 81. This is 10 log 83 base x. It is log 83 base 10. When this power will come in the base, it will become log 83 base x. So on comparison we can say that x is equal to 10. Yes, and x is satisfying as a base 10. Okay, now this type of question I will star mark this type of question. This was asking JEE mains previous year question. So it was from your sheet and it was asked in your JEE mains question. So what will happen is that the trick is that 6x square plus 23x plus 21 is nothing but 2x plus 3 into 3x plus 7. If you see it, sum of the root is this is it, okay. If you will find, it is nothing but log 2x plus 3 into 3x plus 7, which is equal to 4 minus, now this is what I think, this is 2x plus 3 whole square. Okay, so 4x square plus 1. Okay, just got it. Now can we write this as m and m plus n? Log 3x plus 7, 2x plus 3, 4 minus 2 log 2x plus 3, 3x plus 7. Okay, now this is what 1. If we consider this as t, this is 4, this is minus 2 by t. If you consider this is 1 by this thing. Now what can we do is that we can take LCM and start solving. T square minus 3t plus 2 equal to 0. We can get t equal to 2, t equal to 1. Okay, so t is what? T is log 3x plus 7 base 2x plus 3, which is equal to 2. This is log 3x plus 7 base 2x plus 3, which is 1. If you take power, this is 1, this is 2. This will come out to be 3x plus 7, 2x plus 3 whole square. Further solving, we have 4x square plus 9 plus 12x equal to 3x plus 7. Going further, 4x square plus 9x plus 2 equal to 0. So from here we get the value of x as x equal to minus 9 plus minus root under b square 7. 7 will come out to be minus 1 by 2. Minus 1. No, no. From here we are simply getting 3x plus 7 equal to 2x plus 3. So x equal to minus 4. We will have to put this and check it. If x is minus 4, it is what? 12 minus 12 plus 7. So this is rejected. From here we are trying to find some value. We will calculate it, okay? X equal to minus 9 plus minus b square 4ac 7, 8, minus 2, 1 by 4. Okay. X equal to minus 2 minus 1 by 4. Minus 2 if you put, it is 1. The base is going to be 1. If you put minus 1 by 4, it is correct. So minus 1 by 4 is the answer. Minus 2 is rejected. This you can solve it. This you can solve it. This you can solve it taking log base 3 both the side. This I need to solve it. This you can solve it. This you can solve it. This you can solve it. Yes. This you can solve it. Yes. This I will be solving. This I will be solving 2. 1, 2, 3. 3 questions I will be solving. Other than those, I have already solved it. You take it as a homework. So x plus y, we can simply say log xy base 3 is equal to log 18 base 3. So xy is equal to 18. And here we can say that x plus y is equal to 3 cube 27 to the power 2 by 3, isn't it? Which is nothing but 9. So x plus y is equal to 9. So by looking we can say that x is equal to 3, y is equal to 6. 6 3 is 18, 6 plus 3 is 9. So one of the option is correct. 6 comma 3, 3 comma 6 is correct. A and B. This is correct. This you can solve it a quadratic. This you can solve it. This you can solve it. This I will be solving this one. I can say that this is somewhere J advanced previous year question. The product of all the solution of this one will take log base 2009. 2009 x upon 2010. This is nothing but log x 2010 and log base 2009. Base and argument is same, so the power will come out. If we expand it, m minus n. This is log 2009 x minus log 2010 2009 log 2010 base x. It is nothing but if you expand m plus n, it is 1 plus log x base 2009. We'll go slowly and gradually. Okay, this is log 2010 upon log 2009. This is log 2010 upon log x. So we'll form a quadratic in log x. This is what we can do. Yes. So we are getting log 2009. If we multiply log 2009 all side, it is nothing but log x minus log 2010. It is, we are multiplying log 2009 all the sides, isn't it? Log 2010 log 2009 base log x. Multiply log x all the side. Why don't we do s? So it will become log x whole square. We will write it t square plus t into log 2009 upon whole divided by 2010, and this is minus log 2010 log 2009 equal to 0. If you see, one of the root is nothing but log 2010 and the other root is minus log 2009. Product of the root is minus log 2010 log 2009. Sum of the root is 2010 by 2009 minus of. So this is the sum of the root and product of the root. The product of the solution of the equation. So okay, so we can say that this is equal to log x. T is what? Log x. This is also log x. So x1 can be written as 2010. x2 could be written as 1 upon 2009. The product of the solution. So product of the solution can be expressed in the lowest form m by n, which is nothing but 2010 upon 2009. So m minus n is what? 1. This is 1. So we got the simple answer. Okay. Log x base a is equal to b for permissible value of a and x. Then identify the statement. A and b are two irrational number, then x can be rational. If we try to check option A, if a and b are two irrational number, then x can be rational. X is equal to a to the power b. We have to contradict. If we put x equal to root 3, a equal to root 3, b equal to root 2, then x will stay irrational. Take some example which can make it wrong or correct. So I think A is false. No, because if it is what? 3 to the power rational into irrational. So rational into irrational will stay irrational. Okay, so option A is false. B. If A is rational, B is irrational. So same case X is, this is rational. Rational into irrational is what? Irrational. So 3 to the power irrational is maybe irrational only. Irrational. So options 2 is also false. C. If A is irrational, B is rational. So it is x. This is 3 to the power 1 by 2. And this is nothing but 2. So this is 3. So this is rational. So true. We took A equal to root 3, B equal to 2. So this is true. If A is rational, B is irrational. B is rational, then x is rational. Definitely A is equal to 3, B is equal to 1 by 2, then x will become root 3. which is irrational. Can be, must be not. So it can be irrational, or x equal to a equal to 3, b equal to 2, x will be equal to 9. So it can be rational. Like irrational, rational, both are possible, but it can be rational. Okay, this is true, true, true. Okay, before moving with lecture 8, I would like to give you 5 to 10 minutes break. So I will give you 5 minutes break. Let's see how much questions are there. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. This we have already solved. Okay, no problems. 18, 19, 20, 21, 22, 23, 22. Okay, 22 questions are there. So it can be completed. Okay, there is no problem. We'll take 5 minutes of break and then we'll join. Okay, 5 minute break. Okay, so we'll start now. Logarithm equation, logarithm inequality. We completed logarithm equation. Now we'll start with logarithm inequality. So we'll say simply normally like, we'll continue with something normally like let a be a real number. Let a be a real number such that let a be a real number such that first, now I think you all know already how to work. If a be a real number, a be a base, okay, if a is bigger than 1, if a is bigger than 1 and we have log x base a is bigger than log y base b, we'll tell that, no, this is also a, the base are same, okay, we'll tell that x is bigger than y. So normal condition we have that x is bigger than 0, y is bigger than 0. We have such cases, okay. Second condition, if a is we will write it 0, okay, a is between 0 to 1, okay, and we are given some inequality like log x base a is bigger than log y base b, base a only, okay, all the bases are same. Then when we remove the base, inequality will change, okay. Third one, if a is bigger than 1 and we have some inequality like log x base a is less than alpha, what we told on opening the basis, when on removing the basis we'll get somewhere x is less than a to the power alpha, and we'll put x bigger than 0. X should be bigger than 0, yes. Fourth case, if a is bigger than 1 and we are given with the equation log x base a is bigger than alpha, on removing the base we'll get x bigger than a to the power alpha, okay. So these are the very simple condition. When the bases are same, we have few condition on basis. When a is bigger than 1, the inequality will remain the same. If a is between 0 to 1, the inequality will reverse, okay. The inequality will reverse. This is only happening, okay. So fifth condition, if you want to say, if a is bigger than 0, less than 1, log x base a less than alpha, on removing the base the inequality will change because it is between 0 to 1. Now if you remember, yes, it will become x bigger than a alpha. Sixth condition, if a is between 0 to 1 and we have log x base a bigger than alpha, on removing the base I think the inequality is going to change and this x should be bigger than 0, as we know that argument should be bigger than 0. So these are the basic fundamental thing that you should be knowing, and if you know these all, we can proceed ahead in the sense, uh, do we have to take some questions right now? Wait, I'm just telling you. Okay, functional also we have taken right now only, okay. Okay, functional also we have taken right now only. So this was with that, okay. Now 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 nothing now nothing, okay. We'll start solving the question, or we should tell something we should tell now. We should go with now, okay. Otherwise you all will forget everything. You all will forget everything now. Now I wanted to tell that for form 1, if we are given with something log fx base gx, what do we mean by fx? Fx is something a to the power xn, b to the power xn minus 1, something in variable form, and gx is also in the form of a1 x to the power n, b1 x to the power n minus 1, plus dot dot dot. So if such type of things are there and we are given that it is bigger than equal to 0, then what will happen is that we'll follow some inequality. First we'll take condition. If gx is between 0 to 1, for this we will be having fx less than equal to 1. Gx to the power will go as inversion. So fx is less than equal to 0 to the power 1, and this is bigger than 0. Second one, when gx is bigger than 1, if we go with the inequality, it will come out to be fx bigger than equal to 1. So from here we'll solve the variable of x with 1 and we'll get some value. And similarly we'll do and gx bigger than 1. Gx is in the form of x. We'll solve it and we'll get the value of x. B. B, if we have simply log fx base gx and it is less than equal to 0. Now we are expert in solving such type of question. What will happen? First we'll consider that if gx is between 0 to 1, it will become fx bigger than equal to 1, because we'll get fx is bigger than equal to gx to the power 0, which will become fx is bigger than equal to 1. If gx, see in this case we'll take and 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 after getting this value of x, we'll take union. So gx is bigger than 1, we'll take and when gx is bigger than 1, what are the value of x? What are the value of x for which gx is bigger than 1? That we'll get, and by solving fx less than equal to 0, less than equal to 1, bigger than 0, we'll get some x. So we'll do and with both the x, and finally whatever x we are getting, we'll do union of both the x. Okay. C, log fx to the base gx, if it is bigger than equal to a, we'll do the same thing. Gx is between 0 to 1, we'll get fx less than equal to gx to the power a, and this is bigger than 0. We'll get some x value from here, we'll get some x value from here, we'll do and with both and we'll get some value here. Gx is bigger than 1, we'll get some and value there, and fx is what? Hmm, fx is bigger than equal to gx to the power a, we'll get some value, we'll do union. and we get something log fx base gx less than equal to a if gx is between 0 to 1, we'll do and we'll get something fx is bigger than equal to gx to the power a. From there we will get some value of x belonging to something, and we have gx bigger than 1. We will have AND case with both the x. We will get fx less than equal to gx to the power a, which is bigger than 0. This will go with some x belongs to, and finally we will take union of both of them. Yes. So this is how we are going to do. Okay. We have something waiting. Okay. Let's move ahead. Now in this question I will solve it very simply in the sense I will take all the revision cases. Okay, like if we have logarithm inequality, so we'll consider the case of log fx base a bigger than equal to 0, isn't it? This is the case that we are taking. Fx, something in the form of x, is fx and the base is 1 by 5 a. So we know that in this case if a is between 0 to 1, since 1 by 5 is between 0 to 1, we can say that fx will be bigger than 0. The inequality will change, it will become a to the power 0, which is 1. Can we say this is what we are going to get? So from here if we say, it is nothing but 2x square plus 7x plus 7 is less than equal to 1, and this is bigger than 0. Yes. This implies we'll solve them alone if we have such thing. This is bigger than 0 and 2x square plus 7x plus 6 is less than equal to 0. We'll solve them parallelly. So here we are getting d less than 0. If you find discriminant is less than 0, discriminant is what? B square minus 4ac. So b is 49, 56, which is minus 7, which is less than 0. And here we are getting d equal to 49 minus 48, which is equal to 1. So we can simply say that x is equal to minus 7 plus minus root under b square minus 4ac upon 2. This is minus 7 plus minus 1 by 2 minus 4 minus 3. Okay. So it is nothing but x plus 4, x plus 3 less than equal to 0. We are getting two numbers, which is minus 3 minus 4 plus minus plus. We'll get negative part. So x is between bigger bracket minus 4 to minus 3 bigger bracket. So this is the solution we are going to get. Final output. I think you got it. In this question, first thing is that um, this is falling in the version of log fx base a bigger than 0. Is it falling? Yes, yes. And in that it is falling in the case where a is between 0 to 1. Yes, if it is so, we'll take fx, the inequality will change, it will go a to the power 0 and fx should be bigger than 0. So this is 0, fx less than 1. Yes, so here we'll put 5x minus 1 less than 1 bigger than 0, and further we'll go x 5x minus 1 bigger than 0 and 5x minus 1 less than 1. So x is bigger than 1 by 5 and x is less than 2 by 5. So this is correct. X belongs to 1 by 5 to 2 by 5. Okay. Now solving such type of question. Before solving such type of question, I will give you few theory. I will give you few theory. So if you wait for some time, I will give you some theory. Wait. Uh, Wait a second. Wait a second. Okay. Mm-hmm. Wait a second. Okay, I am going to give you some theory, and then we will have a question. Thoroughly some question. Yes, we will have some theory. Okay. We have form 2. In that form, we are told that if we are given something log phi x meaning something written in the form of x. So we call it some function with x. Something written in x is called phi x. Okay, and this is fx. This is bigger than equal to log gx base phi x. Okay, so we will open this again as if phi x is between 0 to 1, we will open the inequality with inverted inequality, which is what fx is less than equal to gx, which is bigger than 0, because everything should be bigger than 0. And second, If phi x is bigger than 1, then fx is bigger than equal to gx, which is bigger than 0. This is how we will open. If you want to take some question, I can take it. Okay, if you want to take some question, I can take it. Simply this question, x squared 2x plus 3. Okay, log x squared 2x plus 3 is bigger than log 2x plus 3 2x plus 3. So for solving this question, what will I do? We'll take when 2x plus 3 is between 0 to 1. Case 1, the inequality will open as x square is less than 2x plus 3 and x square will have to be bigger than 0. Okay, so this is and. Now we'll solve first one. First one will be like 0 is less than 2x plus 3 and 2x plus 3 is less than 1 and x square is bigger than 0 and x square is less than 2x plus 3. We'll find the value of x in every case and we'll take the intersection. Okay, it will be x is bigger than minus 3 by 2 and x is less than minus 1. Minus 2 divided by 2 is minus 1 and here x square is bigger than 0, that means x belongs to R and x should not be 0 because at 0 it is 0. For every value of x this is positive and at x equal to 0 it is 0, but we have to show that x square should be bigger than 0. Hence x belongs to everything but not 0. Yes, got it. Now we'll have and here we have x square minus 2x minus 3 less than 0. Okay, so I think this is nothing but x minus 3 into x plus 1. So the product of the root is 3 into minus 1 minus 3. The sum of the root is minus 2 and it is minus of sum of the root which is minus 2. And here x belongs to R, x is less than 1. Okay, so when you plot this number, we have 3 minus 1 plus minus plus. So x is between minus 1 to 3. Now if we combine all the value, we'll draw a number line and combine all the value minus 1, 3. X is between minus 1 to 3 and 1 is x is less than minus 1. Oh ho, x is less than minus 1 and x is bigger than minus 3 by 2. I think no value of x is coming. Oh, let's check the inequality. Inverse x square. No, in question the inequality is like this. If the inequality is opposite, we won't be getting the answer. There is no solution. Should be like this. Okay. If inequality is opposite, we don't have any solution. So it is plus. X is bigger than 3, x is less than minus 1. So we'll go with some yellow color, okay? So x is less than minus 1, x is bigger than minus 3 by 2, x belongs to R meaning x is not 0 and x is everything, okay? And 1 is x is less than minus 1, x is bigger than 3. So if you see the common part, this will go further, yes. This is going to be the common part. We say it x belongs to minus 3 by 2 to minus 1. Okay. Now this was the first condition. This was the first condition when it is between 0 to 1. We'll go with the second condition. We'll go with the second condition when 2x plus 3 is bigger than 1. From here we get x is bigger than minus 1. Okay. And if it is there, we have and x square inequality will stay unchanged. So x square is less than 2x plus 3. So here if we solve x square minus 2x minus 3 less than 0, we are getting the same thing, x minus 3 x plus 1. Okay. So this is 3, this is minus 1 plus minus plus. So x is between minus 1 to 3 and x is bigger than minus 1. The common part is this one. X belongs to minus 1 to 3. Now from first one we have x belongs to, from first one we have x belongs to minus 3 by 2 to minus 1, and from the second one we have minus 1 to 3. Yes, this is the answer. You got it. You got the understanding. So this question we have already done. Second, form 2. Second, form 2, we are saying that log fx base phi x is less than equal to log gx base phi x. Okay. If this is the case, we'll take one case phi x between 0 to 1. When we'll open, we'll simply get fx is bigger than equal to gx and gx is bigger than 0. Second one, phi x is bigger than 1, implies fx is less than equal to gx and fx should be bigger than 0. So we have to take the union of both the x. Here it is and and of both the x, and then union of both the x. This is how we have to proceed. If you want me to take some question, I will take it question. So it is the similar fashion. Similar fashion you will do both the cases and you will do the union. So let's solve this question. Before solving this question, I will give you few theory of this question, okay? Such that you can revise it. This is nothing but log fx base gx bigger than 0. This is the case if you remember. It was there, yes? So if you go with this, we will consider that when gx is bigger than 0, less than 1, when gx is bigger than 0, less than 1, our inequality is getting changed, isn't it? Fx will be less than gx to the power 0 and fx will be bigger than 0. If you go further, it is fx is bigger than 0, less than 1. So you solve from here you solve the value of x, and from here you solve the value of x, and you do and with both of them. Second case you will get gx bigger than 1, you will get the inequality is to stay the same. Fx is bigger than gx to the power 0, which will imply fx is bigger than 1. From here you will get the value of x, and from here you get the value of x. Take and after taking and you get both the value, and then take union. Okay, so we'll continue with this question. We don't have space. Okay, we will have to take both the cases. Okay, so I think if you got it, we'll start with that. Okay, first case, we'll take gx to be bigger than 0, less than 1, and if it is such so 2x base 5, the inequality will change. It will become less than 1 and this will become bigger than 0. So first we will solve this case. This is what? X square minus 12x plus 30 upon 12x 10. This is less than 1, and when we have 0 we will take and x square minus 12x plus 30 by 10 is bigger than 0, and log base 2x plus 5 is bigger than 0, and log base 2x plus 5 is less than 1. Okay, we'll cross multiply 10 we will have x square minus 12x plus 30. This is x square minus 12x plus 20. We'll do cross multiply. 10 into 0 will be 10. It will be x square minus 12x plus 30 is bigger than 0, and 2 to the power 0 is 1. 2x plus 5 and 2x plus 5 is less than 2. So from here, if we are trying to find something, it is nothing but 10 plus 2. X minus 10, x minus 2. And this is 144 minus 120. It is 24. Okay, so the roots are coming somewhere very difficult. Very difficult roots. Yes, very difficult roots. X equal to 12 plus minus root under b square minus 4ac upon 2a, 6 plus minus root 6. So it is something like x minus 6 plus root 6, x minus 6 minus root 6. This is bigger than 0, and here we have and x is bigger than 5 by 2 and x is less than 5. Okay, so from here we are trying to find something. We'll get something x belongs to minus infinity to 2 union 10 to infinity. X belongs to minus infinity to 6 minus root 6 union 6 plus root 6 to infinity. Okay, okay. Now what will happen? We'll take and of everything. So this is 6 minus 2 point something 4. So this will be the better one. This is 4. So if you take it from here, x belongs to 5 by 2 to 6 minus root 6. This is from 10 to infinity. This is 6 to infinity. So I think one of the answer we are getting. Okay, we are getting only this as an answer. Okay, note this is the answer for the first one which we have solved here. Okay, we will have to go with case 2. Okay, I'm just doing case 2. Gx will be bigger than 1. So gx is bigger than 1. So we are getting some numerical like this. So this will be bigger than 0. Bigger than 0. We'll get x belongs to, oh, this is less than, this is 2 to 10. This is 2 to 10. This is less than, yes. If it is less than, it is 2 to 10. Mm, it will be 2 to 6. No, it is still the same. Okay, and from here we are getting x In this case it will be bigger than 1. We'll get x belongs to minus infinity to 2 union 10 to infinity. Okay, and then from here we'll get x is bigger than 5. That means we will get only one answer. X belongs to 10 to infinity. If we combine this and this, we are going to get x belongs to 5 by 2 to 6 minus root 6 union 10 to infinity. Okay, so this is what we are going to get, and the answer is correct. Okay, uh, how much question to solve? 3x plus 5. We have the same case we solved earlier. Yes, we have the same case we have to solve. This is the same case we have done. If this is fraction, the inequality will inverse and this will become more than 0. So I think I should be giving this as a homework. I think I should be giving this as a homework. All are the same homework type question. Same homework type question. Should I take this one? Homework type question. I feel it is homework type question. Homework type question. No, one question is enough to show all of this. Homework type question. 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 No uniqueness. No uniqueness. No uniqueness. No uniqueness. Okay. Nothing unique. Okay. Okay. I will take this question. Okay. So what will happen? This is base 4, base 4. Okay. The result may be negative. Okay. The outcome of this could be negative. Okay. So what will be happen is that we'll do something like log base 4 x plus 1 x plus 2 minus 1 log x plus 3 base 4 less than 0. Take LCM. Log 4 x plus 3 minus log x plus 1 base x plus 2 log x plus 1 x plus 2 base 4 log x plus 3 base 4 is less than 0. We will have log base 4 x plus 3 x plus 2 x plus 1. mm, log base 4 x plus 1 x plus 2 log x plus 3 base 4. Mm-hmm. We can't do cross multiplication, or otherwise work would have been done. Okay, we'll consider that this whole thing at the bottom is positive. If we consider so, the bottom part, the whole bottom part is positive. If we consider so, we'll have x plus 3, x plus 2, x plus 1 less than 1. And then we'll solve the inequality. Let's solve it. X square plus 5x plus 6 minus x minus 1, x plus 1 less than 0. This is x square plus 4x plus 5 is less than 0, and we have x plus 1. The upper part is always positive, so x is less than minus 1. This is the case when x is less than minus 1. We are told that x plus 3 is positive, so x is bigger than minus 3. Yes, and x plus 1 upon x plus 2 should be bigger than 0. X plus 1 upon x plus 2 should be bigger than 0, and x plus 1 x plus 2 should not be equal to 1. It is not 1. And x plus 3 should be bigger than 0. X plus 3 should not be equal to 1. That means x is not equal to minus 2, and x is bigger than minus 3. From here x is minus 2 minus 1. X belongs to minus infinity to minus 2 union minus 1 to infinity. We are told x is bigger than minus 3, so x belongs to minus 3 to minus 2 union minus 1 to infinity. Okay, okay, this is what it is going to happen. This is the x value, and we are getting this is the x is less than minus 2, so we can simply say that x belongs to minus 2 to minus 3 to minus 2. So when it is minus 3 to minus 2, log x plus 3 base 4 is negative. It is negative, and this is plus 1 minus 1, 1 minus. So this is positive, this is negative. So in this case it is negative, it is always negative. So the inequality will not open with less than, it will open with bigger than. When it will open with bigger than, then we will get x is bigger than minus 1. So answer is x belongs to minus 1 to infinity. This is the answer. So this is higher level question, okay? Minus 1 to a is 1, a equal to 1. This is higher level question. We'll have to think on this. This question is simple. Now we are on characteristic Manchester. Can we take 15-minute break? Can we take 15-minute break? We are taking 15-minute break and then we'll come back. So we have already taken 15 minutes of break. So this is very small topic. I think we are going with the very small topic. Very small, okay. Characteristic and Mantisha. If we are given to find the value of a logarithm which is in the form of log n base a, then greatest integer, then integral integer part of log n base a is characteristic and fraction fraction part of log n base a is Mantisha. Okay, okay. So we can simply say that log n base a is characteristic plus Mantisha. Yes, can we say it? And Mantisha will always lie between 0 to 1. 0 included, it can be 0. 0 included, 1 not included. 1. uh, Characteristic of log of 1 with base 10. Log of 1 base 10 is what? 0. Similarly, characteristic of log 10 with base 10 is what? Log 10 base 10 is equal to 1. characteristic of log 100 with base 10 is log 100 base 10 is 2. Yes, okay. I wanted to add something more in this, okay. I wanted to add something more on this. So I would like to add one more PPT on this because it is not going to end on this much, okay. We have something more to do. So we are waiting for some time. What will happen is that I will show that when negative characteristic is coming, then how can we resolve it? Okay, these all are the things which I am going to show you. Okay, so for that reason, I wanted to add some more PPT to this. Okay, okay. So wait for some time. Can we move? Yes, can we can move? No, no. This is eliminate. Can we move ahead? Yes. So we got characteristic. Now what will happen? We have few small questions. We have very few small question. Question are find characteristic and Mantisha for the following. If we are given A 1.5, 1 is characteristic, zero point 0.5 is Mantissa. B 2.25, 2 is characteristic, 0.25 is Mantissa. C 0.025, 0 is characteristic, 0.025 is Mantissa. D 1 minus 1.25. So we have minus 1 plus minus 0.25. So Mantissa need to be always positive. So we'll add 1 and subtract 1. This is characteristic, this is Mantissa. So we'll note it. Mantissa is always positive. Okay. Mantissa is always positive. Okay. And E number. If we are given something like 1.25, it is nothing but minus 1.25. and similarly minus 2 is characteristic and 0.75 is Mantisha. Okay, note bar over any, no, I think bar over will be minus 1 characteristic plus 0.25 Mantissa. Can it be? I think bar will be minus 1 characteristic plus 0.25 Mantissa. Bar over any number says negative of characteristic, negative of characteristic and the added positive Mantisha. Okay, this is what we are understanding from here. So now what should we do? We should do something more. Interval characteristic, interval characteristic with base 10, numbers of zeros. Okay, zeros immediately after decimal. Okay, this is 1 by 10 to 1. If you do log base, it will be 0.1. 0.1. Point log 10 base 0.1 is minus 1. So characteristic will be minus 1. And decimal after point is 0. Similarly, 1 by 100 to 1 by 10, it will be minus 2. This is 1. So if I give you some question like log with some question like wait, wait a second, I am telling you. if we have log 10 to the power minus 3.5 base 2, can we say it minus 3 log 10 base 2 plus log 5 base 2, which could be further written as minus 3. Log 10 base 2 plus log 10 base 2 minus 1. This is minus 2 log 10 base 2 minus 1. It is 3 point something. It is 6 point something minus 1, which is minus 7 point something. So from here, can we say that, okay, it was 2. It should be 2. Wait a second. कुछ तो झमेला हो गया. It should be 2 to the power minus 3. We are reframing the question. Okay, reframing. It will be minus 3 plus log, or it should be 10 if it is 10, and then this is 10. What they are trying to show. This is characteristic and mantissa. Okay, using this we can find number of things. Okay, let's go with some question. Total number of, when we are told to find total number of digits in the number 18 to the power 50, so how should we find total number of this? We'll take n equal to 18 to the power 50. We'll take log base 10 both the side. We'll get 50, and we are getting here log base 10 3 square into 2, which is 50 log 2 3 base 10 plus log 2 base 10. This is 5 2.4771 plus 0.3010. Now let's calculate. This 5.9542 plus 0.3010. 5, it is 1.2552. This is 0 7 6.2. So here we can say that characteristic is 6, multi-size 0.2750. Okay, so total number of digit is, it was 50, it was 50. Okay, it was 50, so it will be 62.7, 62 7. So total number of digit is characteristic plus 1, which is 63. Okay, now if we are told total number of zeros immediately after decimal, so this is what we were trying to do here. Okay, but we could not get any specific example, so we have to move ahead. This is log 10 base 6 to the power minus 200. This is minus 200, and this is log 2 base 10 log 3 base 10. This is minus 200, 0.3010, 0.4771. This is minus 200. This is 0.7781. If you multiply, you are going to get, first we multiply 2, 6, 5, 15, and 2 0 will proceed, it will become minus 45. So characteristic is minus 155 minus 1, and multiply is, if we add 1, 0.38, it is minus 156. Okay, so numbers of zeros immediately after decimal is mod of C minus 1. That means eliminate negative part, minus 1, which is 155. So it will be having 0, 0, 0, 0, dot, 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 0. It will be 155 times, and then some value A, B, C. Okay, so this is what I was trying to implement there, but I could not get a specific question to implement. Okay, so let's proceed. Now we are on the log table. So now we are on the log table. So can we have some specific question? We will have some specific question, and based on that I will try to say something on log table. We are told that 23.17 to the power 1 by 5.76. Okay, then I should be telling you that anti-log, will take anti-log of log. What will we do? First we will take log base 10, 23.17 to the power 1 upon 5.76. We took anti-log. Okay, first we took log, and then we'll take anti-log. Note, anti-log of A is 10 to the power A. Okay, so we took this thing. From here we will find that what is the value of this number. First we will take log. First when we take log, it is 1.5.76 log 23.17. So how to check this type of thing? First what will we do? We have 10 to the power 1 upon 5.76. We have log 2.317 minus 1. We will multiply with 10 divided with 10. Now what will happen? We will go to log table. In log table if you go, we will find 23. So we have 23 here and then 17. So in 23 we'll go with the first row which is 3636. Okay, so we have 0.3636. Okay, and then 17 we'll go to 7 number on 23. We have 13, so we'll add 13. So we'll give 0.3649. So we have 1 upon 5.76 with 0.3649. So log 2 base 10 is something 0.300, so it is 0.37. We are doing minus, and after this we will get 10. 1 upon 5.76. If it is minus, what should we do? We should calculate it. Okay, so 1.00003649. If you minus it, it is 1536. This is minus of 0.6351, and we will divide finally it by 5.75. This is first we divide it. Okay, if we want to eliminate, 2 will go, 1 2 3 4, 4 will come, 100 will be division. Okay, we are removing this, we are dividing with 100. Okay, 5 ones are 5, 7 6 9 5 1, again 1, 5 7 6 5 1. If we put point 0, so we are getting somewhere 0.11, 0.11. Okay, 10 to the power minus of 0.11 will be 00. Now how to see the anti-log table? Now how to see the anti-log table? It is plus 1. Okay, wait. Okay, calculation was wrong. antilog of a is 10 to the power a. Okay, we are getting this thing 1 upon 5.76. See, this is base 10. So can we say 10 to the power 1 is 10 and 10 to the power 2 is 100. So this value is something 1 plus. We got from 23.17 it was something 0.6330, that you remember, yes? And simply you will come out to be this 1.3630 upon 5.76. This will again come out to be some value 0.2360. Now how to find this value? If we do log and then anti-log, we are going to get the same thing, same value from here. So we don't have any problem in doing log and anti-log. Now when we are going to an anti-log table, this is logarithm table and this is anti-log table. So in anti-log table we have 0.23. So 0.23 is somewhere here. 0.23 will go to 6. 0.23 and 6 is 1722. This is 1722. 10 to the power 1 is 10, 10 to the power 0 is 1. So 1722 0.1722, and we got 0.236 and then we have 0. At 0 we are getting 0 only. Not 0, just we'll consider 0 only. Okay, so we'll add 0 to this 0.000, and 10 to the power 0 is 1. So we'll have 1 plus something. So it is 1 plus 1.1722. This is how it is going to happen. So if you want me to take one more example, I will definitely take one more example. If you want me to take one more example, if you take one more example, like 74.56 to the power 1 to the power what? Take some similar question, okay? 1 by 5.76, okay? We'll take the same thing. We have to find the value of this one. So what can we do is that we have log base 10 74.56 to the power 1 upon 5.76, and this will be 10 to the power. So base will convert and we have everything. Okay, so now first we have 10, 1 upon 5.76 coming out. We have log 74.56 base 10. My saying is that 10 to the power 1 is 10, 10 to the power 2 is 100. So the value of 74 will come out to be 2. So this is 2 plus. Now we'll go on the table. It is what? 74. So 74.56. So 74. This is 5. 8722. 8722. And this is 6. 8726. We have 8722 plus 6, which is 8728. This was the mean value, this was the row value, difference value. So we are going to get something 0.8728. This is 10 to the power 2.8728 upon 5.76. Now when we divide, when we will be dividing, it is 2.8728 divided by 28 divided by 5.76. It will come out to be 10 to the power 0.004985. Our aim is to make it only up to 4 digits. So can we say 0.0050? Now we will go to anti-log table. From here we will go to anti-log table. And from here we will go to log table. Okay. So 10 to the power 00 is this thing. So 0050. So 005 is 10 12. 10 12 plus 0. 10 12 only. So 10 12 and 10 to the power 0 is what? 1. 1.1012. This is the value. I think we are done with the topic. Okay. How many cases could be there?